So in this video, I'm going to work out all of the 4 you tries. Here are the answers here. So I'm going to go through 6, 7, and 8, working through each example to help you out. So we have B is 45 degrees and C is 5. So what we're going to do is draw a right triangle, and it's not going to be to scale, and that's okay. So if I'm given B is 45 degrees, C is 5, we are using right triangles. Now I would at least use kind of how they labeled the triangle here to help you out. So let's do that. So here is A, here is B, here is C. Now the side opposite of angle A is always lowercase a. The side opposite of angle B is always lowercase b. And then the side opposite of angle C is lowercase c. So let's label what we know. Angle B is 45 degrees. Then we know that C equals 5. Now, if this is 45 degrees here, then you must know that this is also 45 degrees. This is actually a special right triangle here. Now let's go ahead and solve like we did previously. Now we know A equals B, right? Because this is a 45 degree triangle. It's isosceles. And so let's solve for this. Given 45 degrees, let's see, we have, let's go with opposite over hypotenuse. And what is opposite over hypotenuse? Well, that is sine. So we have sine of 45 degrees equals our opposite, which is B, over the hypotenuse of 5. Now, because this is a special right triangle, I could use our trig ratios instead to solve this triangle, and that's what I'm going to do. Sine of 45 degrees, if you look at your table that hopefully you wrote down, sine of 45 degrees is square root of 2 over 2, and therefore that equals B over 5. So to solve for B, we're going to multiply by 5 to both sides. So therefore we know that B equals 5 square root of 2 over 2. Now because B is 5 square root of 2 over 2, A is the same exact thing of 5 square root of 2 over 2. You could also plug this in the calculator and solve it as well. And so when you do that, you would type in instead. So if you were solving for this, you would multiply both sides by 5, and then you plug it in the calculator. You would type in 45, then sine times 5 equals, and you would get 3.535. So this is greater, 5 and greater, so you would get 3.54 approximately. Okay, so for number 6, hopefully that helps you out with 6. I just use the special right triangle properties for that, just because that is more exact. So let's try number 7. A is 32 degrees and B is 10. So let's draw our triangle. That's the first thing you should always do. So here is 90 degrees. Then A is in this corner, side A is here, B is here, and lowercase b is here. C, the right angle, and then C, the side. So we're given A is 32 degrees, so 32 degrees. And then what else do we know? We know that B is 10, so this is 10. So given that, we have adjacent, and then we're trying to solve for A and C. So let's first write a ratio for A. So if we're looking at A here, we have 32, so we have opposite over adjacent. So this is the angle, this is opposite over adjacent. So let me just write that real quick. Opposite over adjacent. What ratio is opposite over adjacent? That is tangent. So let's look at tangent of 32 degrees is opposite. Our opposite is A, right? And this is adjacent. So we have lowercase a over B, which is 10. So now we need to solve for this angle. Well, let's go ahead and write the other ratio first. So we have a ratio involving A. Let's write a ratio involving C. So let's use 32 degrees still. So we have adjacent over hypotenuse. Adjacent over hypotenuse. What ratio is that? Well, that's cosine. So cosine of theta. Theta is 32 degrees. So let's write that ratio. Cosine of 32 degrees equals adjacent is 10, over the hypotenuse of C. So now let's solve for A and C. So for tangent, all we need to do is multiply both sides by 10. Then it's a matter of plugging it into your calculator. So again, 32 tangent times 10 and then equals. And so you will find that A is approximately 6.25. And then C, so this is just like the example we talked about before. Now C is in the denominator, so the fastest way to do this is let's trade the places of C and cosine of 32 degrees. So this is going to be C equals 10 over cosine of 32 degrees. So it's similar to the problem we did before. So you would type in the calculator, so just to go over how to type this in, 10 divided by parentheses and then 32 and cosine equals, and you will get 11.791. And so because this is 5 or less, then therefore the answer to C is approximately 11.79. So we have A, which is 6.25. We have C, which is 11.79. What is missing? The last thing we need to do is solve for the angle B. So to solve for the angle B, we can do 90 degrees minus the given angle of 32 degrees here. And then, so therefore, when you do that, you will find that angle B is 58 degrees. So that we solved the triangle completely, we only needed angle B. Remember, we're given angle C is 90 degrees, so we don't need to solve that. We're given side B here, so all we need is side A and side C. So let me go ahead and do number 8 and number 9 as well. Or actually go ahead and try number 8 and 9. Number 9, see if you can use the special right triangle properties. And then I will show the work here for 8 and 9. So here is number 8. And so A is 71 degrees. C is 20. That's the side over here. And so to find the other angle B, we're going to take 90 degrees minus 71 degrees, and we get 19 degrees. So therefore, angle B is 19 degrees. Now, the other thing that's missing is we need the sides. We're given C, so we need to find A and B. So you first find a ratio of, so here's 71 degrees, and we have opposite, so I need something with A, and something we're given. So I'm going to use opposite over hypotenuse. So opposite over hypotenuse, what ratio are we looking at? So we're looking at sine. Sine is opposite over hypotenuse. So we have sine of 71 degrees equals A over 20. Then we solve for A, multiplying 20 to both sides. So A is approximately 18.91. Then we need to find B. So to find B, given 71 degrees, we have adjacent over our given of 20. So adjacent over hypotenuse, that is cosine. So therefore, this is cosine of 71 equals B, which is our adjacent, over hypotenuse, which is 20. Then we solve for B, multiplying 20 to both sides, so we get B is 6.51 approximately. Now number 9, if you drew this out, you would find that this is a special right triangle. So you're given the angle of 60 degrees, and hopefully that maybe you saw that knowing that this is 60 degrees, that this has to be 30 degrees. Now I just use that property because it is so much faster. And so what we are given, this is 60 and this is 30 degrees. Now it's not drawn to scale, but if you know that this is the smallest angle, the side opposite of it will be the shortest leg. Then the side opposite of the 60 degree is the longest leg. And then always the side opposite of the 90 degree angle is the hypotenuse. Now looking at the 30, 60, 90 degree triangle, the shortest leg, now we're given A is 7, which is the shortest leg. Now, because this is the shortest leg, the hypotenuse is always 2 times the shortest leg. So 7 times 2 is 14. Now, given the shortest leg is 7, then the longest leg is 7 times square root of 3. So just remember the properties of a 30, 60, 90. So if this is 30 degrees, this is 60 degrees. The shortest leg is x. The hypotenuse is always 2 times x. And then the longest leg is x times square root of 3. So that's kind of the property to help you out.